to dividing radicals. Things that we need to remember when we are simplifying radicals that are being divided is we are not allowed to have radicals in the denominator in our answer. So we have to what we call rationalize them. So the term rationalizing means we take it from irrational, because if we remember, square root of 5 is an irrational number. It never repeats and it never terminates. So it's a non-repeating, non-terminating, meaning non-ending number. So that would be considered irrational. And fractions in our answers should be rational. So how do we get rid of that radical in the denominator? Well, what's going to get rid of a rad 5? Another rad 5. And since we are making equal fractions, we have this value, this whatever we're multiplying it by, needs to be a value of 1. We don't want to change its value, we just want to change its look, its facade. So in order to keep this as a value of 1, we have to multiply rad 5 over rad 5, which equals 1. So if we look at the numerators, rad 2 times rad 5 gives me rad 10, and rad 5 times rad 5 gives me 5. The 5 pops out, much like when we did that with multiplication. So now we have rad 10 over rad 5, and that is simplified. We cannot simplify the 10 and the 5 because the 10 is in the radical, the 5 is out of the house. So those are unlike, so we can't cross cancel or reduce it by a common factor of 5 because rad 10 is different from 5. All right, let's take another one. So here, there's a couple of ways of doing this. I'd like to first see if we can simplify. Can we simplify this fraction? Does it have a common factor? Yeah. I could break rad 6 into rad 3, rad 2, and rad 15 into rad 3, rad 5. And rad 3 over rad 3 equals 1. So that would leave me with rad 2 over rad 5. Now I can't leave that answer because, unfortunately, it's the same exact problem right there. Oh well. Rad 2 over rad 5 because we have a rad in the denom. No rads in the denom, so we have to rationalize it. When we rationalize it, we are going to multiply by that radical in the denominator. We're going to multiply by rad 5 over rad 5. That gives us rad 10 over 5. That's too bad. That's not too many problems, but here's your third one, and I want you to try it. Let's pause the video and then work it out on a piece of paper. Hopefully you brought your math journal home, and you'll do that. And then when you're ready to see the answer, please unpause it. So if we look at it, there's a number of ways of doing this. The way that I did it is I first simplified by taking the square root of 16. And then I broke rad 20 into rad 4 and rad 5. And rad 4 becomes 2. And then we have 4 over 2 rad 5. And I'm going to simplify the two things on the outside. So I can simplify that numerator and denominator because they're both on the outside. So that'll give me 2 over rad 5. How do I rationalize rad 5? By multiplying by rad 5 over rad 5. And we get 2 rad 5 over 5. Okay? Let's take another look at one. Now we have radicals being divided with coefficients. So remember what we don't like here. We don't like the fact that there's a radical in the denominator. This coefficient has no effect. That's okay. So the only thing that I'm preoccupied here in trying to rationalize is the rad 2. I have to get rid of a rad 2. So if I multiply it by rad 2, that rad 2 becomes a 2. So we get 3 times 2. These two produce this 2. And then up in the numerator, we have 5 rad 10. And we're multiplying the two radicals And notice it's not affecting the number outside the house. So rad 5 times rad 2 gives me rad 10. And that gives me 5 rad 10 over 6. The 6 and the rad 10 cannot be simplified, so that's going to be my answer. I can't do anything more. But notice there's no radical in the denominator now. There's a rational number in there. Now, here's an opportunity. We just did one of those, but this is an opportunity for you to try this problem. So pause the video and give this one a shot. When you're ready, unpause the video to see the answer. So looking at this, the first thing again I would do is try to simplify that fraction before we rationalize it. I'm going to take the square root of 4, which is 2, and once I do that, I can cross cancel again. The 2 and the 4 are outside of the house, so I can cross cancel. There's a factor, common factor of 2, and that leaves me 3 over 2 rad 5, and we're going to multiply by rad 5 over rad 5 in order to rationalize it. We get 3 rad 5 over 2 times 5, which is 3 rad 5 over 10. And here's our last example. Maybe not the last one, we might have 2 more. Now we have variables. So that definitely adds the intricacy. So what I'm going to do is I'm going to separate each of these into their own separate radicals. It's not a bad thing. I don't know what's necessarily going to happen. I'm going to do this problem 2 ways. I'm going to do it this way first, and we see that we have a perfect square, and we also have a perfect square in the denominator. So we can do 3v, because the square root of v squared gives me v, and then we're left with 2u up in the top. We have 2u, because the square root of u squared is u, and then we're left with 3v. And now I should rationalize. I have to get rid of this radical, so I'm going to multiply by rad 3v over rad 3v, and that will give me 3v, and then I'm going to multiply these 2 radicals. This radical times this radical, so 2 times 3 gives me 6, u times v gives me uv. And what am I left with in the denominator? I'm left with 2u times 3v, rad 3v times rad 3v is 3v. And I'm going to cancel this 3v in the numerator with that 3v in the denominator. And my final answer is 6 rad 6 uv over 2u. Notice I can't cancel the 2 and the 6 because the 6 is in the radical, the 2 is outside. And I can't cancel the u's because the u is inside the radical in the numerator, and the u is outside the radical in the denominator. I'm going to redo this one, and I'm going to show you another way to do this. Let's copy. Another interesting way that will probably be helpful for everybody to see is, remember, we can put those radicals in the same rad. If they're both under radicals, then we can put them under the same house. And the reason being I would do this is I saw that I have like variables, and I can simplify that. So this becomes 3/2 times 2. So the u in the numerator cancels, and the v in the denominator cancels. So I'm left with 2v over 3u. And now I can rewrite them with numerators and denominators. And I need to rationalize. So I have to get rid of that denominator, that radical in the denominator, which is 3u. And that leaves me with, let's do it underneath, 3 6uv over 2 3u. and we know those 3's will cancel, and that leaves me with 6uv, rad 6uv over 2u, which should be the same answer. Yeah, two really good different ways of looking at it. Important for you to understand the different ways of tackling radicals when they're in fractions. Let's look at this problem. So the first thing I would do is I would cancel the things on the outside. So that leaves me with 2 in the denominator. I can cancel these 2 with 2 of those. So I'm left with rad 5 n squared over 2 rad 2. And this is where it gets, see, showing it, I should be doing a better job of showing each of the steps, but you would technically, I almost lost that 2 there. So keeping track of your work is very important. Let's separate the rad 5 and the rad n squared, because the n squared is a perfect square, so that gives me n rad 5 over 2 rad 2. Let's rationalize it, and I'm left with n rad 10 over 2 times 2, or n rad 10 over 4. Good. All right. Oh, was that a U try? Uh-oh, I forgot to. Whoopsies. I forgot to clone the U try page. Let's clear ink. That was ink. I don't want you to clear. What happened to the problem? This is not working very well. Clone page. I want you to just erase. Oh, I probably did clear page, clear ink. There we go. So now that you've probably already seen the answer, but you can practice it and try it. Hopefully you were distracted by my moving things around. So try this problem, 2 rad 3n over 5 rad 6n to the 4th. Pause this video, show your work, and then unpause it when you're ready to see the answer again. All right, so if we look at this problem, one of the ways of doing this problem would be to separate the rad 6 and the rad n to the 4th in the denominator. The n to the 4th in the denominator is going to be a perfect square. So the square root of n to the 4th is n to the 2nd. And then we have, then I would break up rad 6 into rad 3, rad 2. And that would allow me to cancel the rad 3 in the numerator with the rad 3 in the denominator. They cancel to make 1, not 0. They cancel to make 1. So we're left with 2 rad n over 5n squared rad 2. We have to rationalize it by multiplying by rad 2 over rad 2. And that gives me 2 rad 2n over 5n squared times 2. Again, we're going to cancel like factors in the numerator and the denominator. And my final answer is rad 2n over 5n squared. If you have questions, feel free to stop by for office hours, and we will go over those. Thanks, and enjoy.